Welcome to HFC Squared, the Hydrogen Fuel Cell channel, where we will explore the exciting world of hydrogen fuel cells. In this episode, we will go where no scientist has ever gone before and uncover mysteries that have been unsolved for centuries about the profound element that has frequently gone overlooked. So take a seat and keep your Advil handy because your mind is about to be blown.
Papa l'americano. Papa l'americano.
So, you might be wondering, what makes a good chemical fuel? Now that's a great question. Let's take a deeper look at this. A good chemical fuel consists of 6 main elements: energy content, octane rating, volatility, corrosion, speed of reaction, and activation energy. Shall we now take a deeper look at all this? I think so. Energy content. Energy density measures how much fuel stores per unit volume. Hydrogen has variable densities due to a change in temperature and or pressure. A good fuel has high energy content. Octane rating. Some internal combustion engines exhibit an unwanted behavior called knocking. Knocking is when pockets of the gas-air mixture in a cylinder don't ignite at the right time. Depending on the fuel, knocking happens more or less often. Good fuels have a higher octane rating. Volatility. Volatility measures a liquid's tendency to evaporate. The desirable volatility for fuel is one in which it is somewhat volatile, so that it can mix with air, but not so volatile that it exists almost entirely in the gas phase because it's more difficult to store. Duh. Corrosion. Corrosion is another factor that must be taken into consideration. For example, no one wants a fuel source that speeds up the rusting process, damaging the system the fuel is used in. Ideally, good chemical fuels don't corrode or harm the system. Speed of reaction. The speed of reaction is important. You don't want your fuel to take as long as rust. Chemical reactions involve breaking bonds between existing molecules and a formation of new bonds between atoms. The breaking of bonds always requires energy, whereas the second step releases energy. If the first step requires less energy than the second consumes, the result is a net release of energy. It takes energy to make the initial steps of the reaction to happen, but after the initial energy barrier, it explains why you need to supply heat or spark to make wood or gasoline burn. Oh, hi. Activation energy. If the activation is too high, you need to have a huge amount of energy to make the reaction take place. So that is undesirable. If it's too low, the fuel detonates before we want it to burn. Or it's very unstable and dangerously reactive, which is also undesirable. We want an activation barrier in between the two extremes.
Did you know?
Hydrogen is odorless, colorless, and non-toxic in its gaseous state, and almost 14 times lighter than the air people breathe. Hydrogen is the most abundant element in the universe, but it rarely appears alone and must be extracted from other substances. There are many different ways to do this, such as renewable solar, wind, and hydropower methods, or using radio waves upon seawater. However, the cheapest and most common method is steam reforming, where natural gas and steam create a chemical reaction that creates hydrogen and carbon dioxide. This method produces almost half the hydrogen available today. However, this is still very costly. Let's hear some thoughts from Roy Kim from the California Fuel Cell Partnership. Roy?
Hello, I'm Roy Kim. If we can develop a method that can be mass marketed to produce enough fuel, it would be a great addition to the diversity of feedstock we can use to produce hydrogen.
Thank you, Roy.
Thank you.
Did you know? Did you know? Did you
Because of the
know?
high cost to build fuel cells, large hydrogen power plants won't be built for a while. However, fuel cells are being used in some places as sources of energy power, from hospitals to wilderness locations.
The other day, I was doing some research on the disadvantages of hydrogen fuel cells.
No way, I was doing the same thing for the advantages. Do you want to ponder our notes?
Sure. Well, like, one disadvantage is definitely that the fuel cells are currently very expensive.
But since they have a simple construction, mass production costs will become extremely low.
But the prototype fuel cells last only 1/5 as long as would be needed to make fuel cells cost efficient.
Well, fuel cells combine the best batteries since they're quiet and no emissions, and internal combustion engines since it's easy refueling once the infrastructure is in place.
But they are energy losers because it costs more to produce hydrogen than is earned by using hydrogen in fuel cells.
Well, they are far more energy efficient than gasoline fuel vehicles, with double the efficiency of internal combustion engines and far less polluting.
But the electricity generated by these fuel cells in cars costs thousands of dollars per kilowatt. This would have to fall by a factor of 10 for fuel cells to become economically viable.
Well, there's been a tenfold increase in the power of destiny of fuel cell stacks and a tenfold decrease in their cost within the past 5 years.
Maybe they aren't that bad.
Well, maybe they are.
Oh! Sorry, you caught me at a bad time. I was just playing a quick game of Quidditch. But now that you're here, I might as well talk to you about our fuel's development. Hydrogen is combined with air to create an electrochemical reaction that produces electricity. This is done a lot more efficiently than your local power company. Unlike combustion engines, hydrogen fuel cells don't burn fossil fuels. Their main byproducts are water and heat, so there are no polluting emissions. The amount of power produced by a fuel cell depends on several factors, including fuel cell type, cell size, the temperature at which it operates, and the pressure at which the gases are applied to the cell. A single fuel cell produces enough electricity for only the smallest applications. Therefore, to provide the power needed for most applications, individual fuel cells are combined in series into a fuel cell stack. A typical fuel cell stack may consist of hundreds of cells. As you can see here, the electrons prevent the hydrogen and oxygen from mixing. They also transfer protons from anode to cathode.
Did you know? Did you know? Did you know? Hydrogen is an energy carrier, not an energy source, meaning that it stores and delivers energy in a usable form.
Oh my gosh, I am so embarrassed. You caught me coming home with my brand new combustion engine boat. This is embarrassing.
Hydrogen fuel cells are so much more efficient. They're pollution-free and have 2 to 3 times more the efficiency than traditional combustion technologies. Hydrogen fuel cell systems can generate electricity up to 60%, but regular combustion-based power plants usually generate efficiencies of only 35%. Gasoline engines in a car are less than 20% efficient in converting energy to move the car, but fuel cell vehicles use electric motors, which are much more efficient. They only use 40 to 70% of the fuel's energy. They also operate much more quietly.
Did you know? Did you know? Did you know?
Hydrogen is one of the most plentiful gas in the universe. Stars like the sun
entirely of hydrogen.
So, I bet you're wondering the impact that hydrogen fuel cells have on the environment. Well, first of all, there are many problems associated with combustion engines that we run today. For example, burning gasoline releases carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxides, and hydrocarbons into the atmosphere and can extremely damage the environment. Not to mention, the price of oil is very changeable and frequently the price of barrel rockets. Also, nitrogen oxides can react with organic matter in the atmosphere and form smog. This is what contributes to respiratory problems and global warming. Hydrogen fuel cells are pollution-free and renewable through wind, solar, and hydropower sources. Hydrogen fuel cells will not cause very much harm to the environment or our health because its only byproducts is oxygen and a trickle of water. Because of their high efficiencies, they will be a significant contributor to reducing emissions and greenhouse gases. For example, a fuel cell operating at 60% efficiency would emit 35 to 60% less CO2 at fossil fuel stage and 80% less from hydrogen. Some people believe that they will have some environmental drawbacks because the process of burning fossil fuels to obtain the hydrogen will release carbon dioxide into the air, which is one of the leading causes of global warming. Other scientists say that the carbon dioxide release will outweigh the environmental benefits of a clean burning energy provider. So I have my friend John Haywood here, and he has something important that he wants to tell you guys.
Hi. If the hydrogen does not come from renewable sources, then it is simply not worth doing, environmentally or economically.
Wow.
Thank you.
Hydrogen fuel cells would be very helpful in communities like Toronto, where it is estimated that air pollution is associated with 1,700 early deaths and 6,000 hospital visits every year. Dr. McNone is even noted in a 2007 report that better transit is key for reducing the 440 smog deaths caused by vehicles on the road in Toronto each year. There are also already 2 hydrogen fueling stations set up in the city. Hydrogen fuel cells would not only reduce the pollution being emitted into the air, it would also save lives.
Mayday! Too many fossil fuels!
That's all for now. Thanks for tuning in.
Which gets all the rock and roll, which gets all the rock and roll, which gets all the